All right, lesson 2.10 for 9:30. We are going to talk about these things called linear transformations today. So that's a fancy word for just saying what happens when we change part of the equation and how does it affect the graph. So we're going to recognize what happens to the graph when the slope changes, the m in an equation, and what happens to the graph when the y-intercept changes, the b in the equation. And then we also want to make sure that we understand how that affects it when we are looking at lines in a graph and be able to tell just by the graph what has changed in the equation. So both what happens to the graph when we change the equation and then vice versa. If I look at the graph and see some changes, what has happened in the equation. So both directions is what we're going to focus on today. So your warm-up today, hopefully you've looked at this already. This isn't too tricky of a one, but just to kind of get your brain in the mode of recognizing differences in graphs. So what do you notice is the same in these two graphs, and what do you notice is different? So if you haven't taken a shot at this one yet, go ahead and pause the video and write some thoughts down. So when I look at this graph, I notice that it looks to me like the slope of those lines are the same. I could double check by just saying, all right, here's a point and here's a point on this first one. So it looks like it's a rise of, ooh, be careful. It's a rise of 2 and a run of 1. And then if I look over here, I can see, oops, I didn't mean to, here we go, between these 2 points, here we go. And here it's also a rise of 2, notice the scale of the graph, and a run of 1. So the slope is the same. Now, if I really look at what we're talking about here, that's the cost of bowling at Brunswick Bowling Alley compared to the cost of bowling at Strikeout Bowling Alley. And so the slope of the lines, that's like the rate, right? That's how much money it costs per game. So for both of them, it would mean that it is $2 per game, right? So that's the same between the two bowling alleys. What I see as different about the two is the y-intercept, right? For Strikeout Bowling Alley over here on the right, my y-intercept is at 0, meaning all I have to pay for is the cost of each game, right? If I don't play any games, it's $0. If I play one game, it's only $2. So there's $0 to start over here for Strikeout. But over here at the Brunswick Bowling Alley, they have a one-time fee of $4. So it's $2 per game, but if I only play one game, it's actually $6 instead of $2. So here they have a $4 starting fee. Now, what do you think that might be? I think maybe that might be $4 to rent shoes, maybe, or just a lane rental fee, or something like that. Something about a one-time fee for the Brunswick Bowling Alley that they do not have over at Strikeout Bowling Alley. So what's different about them is the y-intercept. So that just kind of got your brain moving on looking at the similarities and differences between two graphs, and then kind of connecting them back to real life and what they might mean. So let's really think about it here. So first of all, we're going to say, okay, if I have two equations and all that I change is the y-intercept. So if the only thing that changes from one equation to the next is b in my slope-intercept form, then what's going to happen to the graph? So this right here has a little link to a quick demo video showing you on a graphing calculator. This is actually using Desmos.com. What happens when you change the b in a graph. And it's way easier to see it live action happening right in front of you than for me to sit and graph all these lines. So if you haven't watched this video yet, pause it now, take a look at that video in the clip right there, and then we'll come back to it. So if you saw in that video, a change in the y-intercept, b, causes a translation in the graph, right? So increasing b, if you make B larger, right? Farther from 0. If you make B larger, you increase B, you're going to move the graph up that number of units, right? So increasing B moves the graph up that many units. And by the graph, I probably should, a better way to say that would probably be to say moves the line up. Okay? And if you decrease B, if B gets smaller, it moves the line down that number of units, right? So if you increase B by 2 units, that's going to move the line up 2 units. If you decrease B by 5 units, it's going to move the line down 5 units. That was probably pretty obvious. You probably weren't too shocked by that revelation there from that demo because, we kind of understand what B is. It's where it crosses the y-axis. So making B bigger would mean that it crosses the y-axis at a higher point. So hopefully that was a little bit straightforward, but at least you got to see it and know for sure. But the good math vocabulary for that is called a translation. So we have translated that line up or down. All right, so that's what happens when I change B, but what happens if I change M, the slope? So here again is a quick video. This one's a little bit more complex because there's a little bit more going on with a slope than there was with y-intercept. But still, it's a pretty short demo video, again, using Desmos.com, so you can see in real life, real time, what's happening when you change the slope in an equation and how that affects the graph. So if you haven't watched this video yet, go ahead and pause now and take a look. So as you just saw in that video, what happens when you change the slope is that it changes the steepness of the line, right? So changing the y-intercept causes a translation. Changing the slope changes the steepness of the line. Now, it is a little bit tricky to describe, right? Depends if you have a positive or a negative slope. But the easiest way to describe it says that if you have a slope that's farther away from 0, that means that you have a steeper line, right? M farther from 0 means you get steeper line. I don't need the word that in there. You get a steeper line that the farther away from 0 the slope is. The closer to 0 that M is, the flatter the line is, or less steep, however you want to think of that. I never can figure out the best way to describe that. Less steep, flatter, however you want to think of it. Lots of S's in a row there, sorry about that. Okay, so closer to 0, flatter the line, right? Farther from 0, steeper the line is. And remember, as I showed you right at the end of that video, the reason there is because, what does a line look like that has a slope of exactly 0? When you have a slope of exactly 0, you have a horizontal line. So the closer your slope is to 0, the closer it's going to be to a horizontal line, which is pretty self-explanatory, right? Whether it's negative or positive, the closer you get to that slope of 0, the closer you are to a horizontal line. When you hit exactly 0, it's exactly horizontal. The farther away you get then, the steeper the line gets till you get as far as you possibly can, which is a vertical line, right? So that's again a one that should be easy to remember, but maybe wasn't something that you knew already. So changing the slope changes the steepness of the line. Farther away from 0 is steeper, closer to 0 is flatter. Okay, so let's see how we can use that. So here's where we were talking about how if I look at a graph, can I tell just from the graph what's changed in the equation without actually having to write the equations out. So here it says this graph shows a blue and a red line. So what changed in the equation to go from the blue to the red? So the blue one is my original, and the red one is the new one, right? So from blue to red, what changed? Well, if I look at those two lines, I see the steepness is exactly the same. You could count it out, right? You could count your rise over run. If I see Here looks like a point, and here looks like a point. It looks like my rise is 2 and my run is 3. So my slope for that one is 2/3 if I wanted to actually count it. And looking over here, rise of 2, run of 3. Slope of this one is exactly the same. So the slope didn't change. But what happened is I see that my y-intercept has changed, right? And to go from blue to red, go from blue to red, my y-intercept must have decreased. Decreased, right? It got smaller because my red line is below the blue line. And for to be exact, it decreased 1, 2, 3, 4 units. Now I could go so far and actually write both of the equations because it's not too hard to write those equations in slope-intercept form, but just to be able to really recognize what happens just between the graph without writing the whole equations out. I can tell that the slope is the same. All that changed was the y-intercept has decreased by 4 units. That's what we're getting at here. So take a look at this one then. Here again, blue and red line. What changed in the equation to go from blue to red? So blue is the original, red's the new one. What happened to go from blue to red? So on this one I see they are both crossing the y-axis at the same place. So the b stays the same. So the y-intercept has not changed, but I see that the red line is steeper than the blue line, right? So M has gotten farther from 0 than the blue. And that's all that we needed to get at. You don't have to actually count it out. I'm sure you could. You could find the points and actually solve it out and see if you're correct. And if you want to, we can just double check here. These look like 2 points. So my slope for my red is 1, 2, 3 over 2, right? So slope of my red line is 3/2. And the slope of my blue line, let's find some points here. Here's 1, and looks like here's 1. This looks like a rise of 2 and a run of 3. So my slope for my blue line is 2/3. So is 3/2 farther away from 0 than 2/3? Yeah, you bet it is. 2/3 is less than 1. 3/2 is greater than 1. So M is farther from 0. But all I was looking for is this part right here, right? That you understand what it means when the slope has changed, when that line is changing steepness, what has happened in the equation. So an M farther from 0 is what we're looking for there. Okay, so we looked at graphs. We could understand what has changed in the equation based off of the graph. How about this one? So again, blue and red, what has changed to go from the blue line to the red line? So the blue is the original, the red is the new. Again, I see my y-intercept has stayed the same. They both cross the y-axis in the same place. But here I would say, wow, my slope has changed a lot, right? The blue line is pretty steep, although it is negative. The red line is a little bit flatter, but it is positive, right? So I can't really say increase or decrease, but the red line is definitely flatter, which means that my slope has gotten closer to 0. Hey, take a look at those lines. How would you describe those two lines? You might say that those two lines are perpendicular, right? So just as a quick review, we could talk about our slopes of these two lines, and we know in the back of our minds what perpendicular slopes should be, right? So here are 2 points for the blue line, my original line, and it looks like my slope was down to -2 and run 1. So my slope of my blue line was -2 over 1. Slope of my red line looks like I had a rise of 1 and a run of 2. So my slope was 1/2. And sure enough, opposite and reciprocal for perpendicular lines. But we wanted to say what changed from blue to red. So yes, they're perpendicular. But is it true that my line got closer to 0, my slope, got closer to 0 from blue to red? So my blue was at -2, and my red was at 1/2. Yeah, that red one is absolutely closer to 0 than -2, right? So even with perpendicular lines, it still works. All that stuff still goes into play, even when you're talking about those special cases, right? So just keep that in mind. And here again is just a quick, another refresher with those parallel and perpendicular lines, because those sometimes throw us off. All right, I feel like you guys are probably pretty solid on looking at graphs and seeing what happens. So let's go the other way then. Can I understand when I change something in the equation, how it changes the graph? So here's a little real life scenario. So a gym charges a one-time joining fee of $50 and then a monthly membership fee of $25. So the total cost Y of being a member of this gym is given by the equation Y equals 25x plus 50, right? 25x plus 50. Here we go. Where x is the time in months and then y is the total cost. All right. So first of all, it says to graph the original equation. So we're going to graph this equation right here. So again, one-time joining fee. So we start at positive 50. And then I rise $25 a month. Now take a look at our scale here. So every line here is 1 unit. So 1, 2, 3, 4, 5, 6. Okay, so even though they're only labeled every other, they're 1 unit on the x-axis. On the y-axis, let's see, 2 is 50, 4 is 100, so that looks like I'm going by 25s, right? So just to make sure that you really catch the scale of that graph. So if I want to go up 25 for every month, that means that the next month, at month 1, it's going to be $75. At month 2, it's going to be 100, and so on, and so on, and so on, right? So we should be able to draw that line. Now again, we're going to assume you can actually draw a line here, because you probably have to pay, even if you cut off at some point in the middle of the month, you probably have to pay for however much you were there. So the line does make sense here. And we would have an arrow on the end because you could join for as long as you live, right? So we do have an arrow on one end, but I can't have negative months. So not an arrow on both ends. All right, so there's my original equation. Now, number 2 is where we are. It says sketch a new line if the gym decreases the one-time joining fee. So first you need to understand and really think about that. Go back to that paragraph and understand what the numbers are. Is the one-time joining fee, are they talking about the slope or the y-intercept? The one-time joining fee, that was the $50. That was the y-intercept. So you need to graph a new line if the gym decreases the y-intercept. All right, so there's a lot of different possibilities here, right? But the slope has to stay the same. So I need to continue to be, my slope needs to be 25 over 1. So I need to continue the same slope. So it needs to be parallel to that blue line. But I have to have a decrease in my one-time joining fee. So you could put it right here at 25, say, and make sure that it still goes unit by unit underneath it. I mean, it could be underneath that. It could be down here and still going at the same slope. It could be closer, right? But it can't be above, because it does say that it needs to have decreased the one-time joining fee. So here's an example of one that it could be. All right. So same situation. I saved you the time on this. I have the line graphed already for that original equation, the one-time joining fee of $50, monthly membership fee of $25. I want to see if you guys this time on your own can draw me a new line to say if the gym increases the monthly membership fee this time. So pause the video and see if you can do it. So if we're talking the monthly membership fee this time, this would be that $25, right? This was the slope. So this time we are going to increase M. So since I have a positive slope, an increase really means farther from 0, right? So what would my line look like if the slope was farther from 0? My y-intercept needs to stay the same. The one-time joining fee is still $50, but my slope is farther from zero. Farther from zero means steeper. So I need a steeper line than this one. So it could be something like this. It could be something like this, right? Could it be straight up and down? Probably not, right? That means that they're just going to charge you an infinite amount of money for every month, and that doesn't quite make sense. So make sure it makes sense in the problem, but it could be fairly steep. Who knows? Jim might be really desperate for money, and that could be what they need to do. All right, so hopefully you got the idea of how to sketch new lines based off of changes in the graph, but also looking at graphs, be able to understand what changed in the equation. So that kind of wraps up what we're talking about for linear transformations. So just remember, changing the slope changes the steepness of the line. Farther from zero, the steeper the line. Closer to zero, flatter the line. Changing the y-intercept, the b in the equation, translates the line, causes a translation. Increasing the b moves the line up, decreasing the b moves the line down. All right, so you got some practice problems here for your homework, and then make sure that you are asking your teacher those questions if you are confused about anything.